let us begin. It's going to be like a marathon, okay?
Okay.
More like a sprint of a marathon.
Good luck.
Okay. Okay, here's a cell. What's high concentration inside the cell? What's high concentration outside the cell? And give me their charges, okay?
Potassium is positive, calcium is positive, chlorine is negative,
Sodium.
Sodium,
is positive,
Okay, what's the general charge inside the cell?
Potassium.
negative.
Negative. What's the general charge outside?
Positive.
Okay. What are important channels that you need to be aware of?
Ligand,
Ligand?
Ligand.
Ligand and ligand.
Ligand.
Different people say it different.
Okay.
It's just one of those words.
Because I call it like
Lots of people say ligand, I say ligand, whatever. But yeah.
Ligand-gated sodium channel, ligand-gated potassium channel.
yes.
Okay.
And the potassium
Well.
leak channel.
So
Yeah.
this is going to be a ligand gated, so I'm going to put a little receptor on it. Okay, so that's going to be sodium.
And then that's potassium.
Then there's potassium what?
Ligand gated channel. Isn't it?
Ligand, there
Ligand-gated
probably is, but
potassium.
you're thinking of a voltage.
Oh, voltage.
Oh,
That's
I
what
see
it was.
voltage.
So,
Because we're all like, ah, okay.
so I'm going to put, so this is potassium, this is sodium.
Why is it voltage rather than ligand gated?
Because it opens it once the voltage inside the cell hits the...
A certain point.
Yeah,
Oh,
so that's
okay.
why it opens
Yeah,
it.
basically it's, you say, I'm trying to remember if it's ligand gated sodium channel or sodium. Okay, yeah, it's
It is
ligand gated
ligand-gated
sodium.
channel.
So you say how it opens and then what goes through it.
Yeah.
So how does it open? A ligand binds to it. So it's a ligand gated, what goes through? Sodium. Ligand gated sodium channel.
Okay.
Sorry, I had to write down the time, I didn't do that. Okay. And so like the voltage ones, it's a voltage gated sodium channel or a voltage gated potassium channel. Then there's also potassium leak channel you should be aware of. And
Oh, there's the
Negative.
potassium, sodium pump. ATP pump.
So there's the sodium potassium pump, that's really important. The thing that you're thinking of, the calcium one, that's a specific example that Brother Baker used, talking about secondary active transport in the heart. So that's not going to be found in all
So
cells.
sodium,
but yeah.
potassium.
So the sodium potassium pump,
Is
how
that
much
the
in,
ATP
how
pump
much out?
though?
2.
2 and 3 out.
Yeah.
2 of what in?
Potassium. And 3
2 potassium in,
sodium.
3 sodium out for every 1 ATP used.
The calcium that he was talking about, that was the cardiac muscle, wasn't it?
Yeah,
Okay.
yeah, that specific pump is,
And is that where you have the plateau phase?
yeah,
Okay.
yeah.
I'm thinking,
That's way further than you need to know right now.
No,
Good
I-
job.
I'm thinking 265 right now.
Okay,
Oh,
cool.
wow.
Gotcha. I was
And
like,
labs and chemistry.
I was like, that
John,
is
you're
a lot
right.
further than you need to know, but yes, correct.
No, I
That's
need
the
to know
plateau.
right
Okay.
My brain's like,
You've all
I'm
seen
impressed.
this chart, correct?
Seriously.
Yes.
Yes.
Yeah.
Yep.
Okay. What is this chart talking about?
action, the rest
Okay.
of them.
Actually, technically, so this is an action potential, but this chart, it's not
Oh.
charting action potentials.
The RMP.
RMP.
Electric gradients?
Yes, but no. So electric,
it's
not
the
gradient.
It's the difference between it.
The difference of electricity, the difference of charge between the inside and outside of the cell. Okay?
Okay.
So, for example, inside the cell, it is relatively negative, right? That's why our
Oh,
negative
yeah.
inside a neuron is about negative 70. Okay? And then, so for an action potential to happen, what starts an action potential generally? The example that they gave you. That starts an action potential was the first thing.
Like touch and some kind
Like
of
sensory.
stimuli.
So what?
Are you talking about like sensory neuron?
More searching for what he was talking about, but you're not wrong. But yeah, so there's, so it's either a ligand-gated sodium channel or there's some other things I can do, but usually they refer to the most in this class about the ligand-gated sodium channels. So sodium channel opens, okay?
Yeah.
Sodium's gonna flow where if a sodium channel opens? Inside the cell.
Yeah.
that's gonna cause the cell to become more positive or negative?
Positive.
It's
More
gonna
positive.
Depolarize.
So depolarization. Okay, so this is only talking about the charge. That's what this graph is talking about. And so it's easy to step by step through this graph when you understand what it's talking about specifically. Okay?
Okay.
Trying to think.
My,
You s-
my question was how those different things affect the action potential. So
Like
how if
hyper-
there's more calcium outside the cell, how that affect?
Oh, the EMS.
Yeah,
The EMS. And I went and I,
I talked to him too.
yeah. Okay, so you understand how, like, so if something's flowing in, you understand how that affects the resting membrane potential, correct?
Yes.
Okay, so we're talking about the axon of the neuron right now. So that's where action potentials are going to be occurring. Okay, so there's a couple different EMEAs. What does EMEA mean? EMEA, there's natremia, calcemia, calcemia,
Oh, it's blood. Blood.
so it's blood.
Yeah.
Okay, so in things like, so there's hyper and hypo for each.
Yeah.
Let's-
Oh, beautiful. You are a good artist.
Or a good copier, whichever one.
Yeah.
Good artists are good copiers. That's what they do.
Touche.
Okay,
Good idea too.
so there's hypo and hyper, natremia, calcemia, and calcemia. Okay? So what does hypernatremia mean?
Sodium.
High sodium.
So that would
Okay,
hypopolarize
So-
the.
give me 1 second before we jump off the ladder. Okay, I'll let you jump, but give me 1 second. Okay, so in each of these examples that are talked about, there, so if you get a lot of sodium in your blood, how did it get there?
Some salty food.
Okay, so that's one way, had a lot of salt. Or different things that got injected into you, or different ways. But we never find just out in nature, we don't just typically be like, oh, here's a sodium ion by itself. It always is paired with something, such as sodium chloride, or things like that. So there is a neutral charge being input in all of these, put into the blood. Super important,
Oh.
or else everything will be super confusing.
So then when it goes through it, because it's specific, what's the word? The channels are very specific on what they let
They have
in.
specificity.
Specificity,
Mhm.
when they let it in, that's what creates the
Okay.
change.
So if we have a high amount of sodium outside the cell, will the resting membrane potential go up, down, or stay the same?
Stay the same.
Stay the same, because you have a lot of a neutral charge out here,
So that's why it doesn't affect
but
it.
there's no way for the sodium to really get in.
So that's why
or-
it doesn't affect
yeah.
the.
So it doesn't really affect the resting membrane potential. What about
He
hyponatremia?
never
Same thing.
told me.
Same thing. Okay.
Right.
There's one really important thing to know about calcium that makes it a little bit different. What does calcium function? What's one of its functions that it does affecting these gates?
It keeps the sodium gate closed.
It keeps
The ligand
the
gated.
the voltage. It keeps
Oh, it
voltage.
keeps the voltage one shut?
Uh-huh. It keeps it closed. So that's how it stays closed. Is calcium binds to the outside of it, and it stays like that. It stays like that until it until the cell depolarizes, and then it kicks off and it can open up. Okay? So knowing that, because that's an important tidbit of information.
Yeah.
What would happen with hypercalcemia?
So the sodium voltage gate would close more of them, right?
It would close more of them because
So
at
it
rest,
Because at rest it's.
there are a couple that are open. You just don't talk about them because they don't have a big
So it would
impact.
or it would
It would hyper.
hyperpolarize, yeah.
So it would make it go down.
It would depolarize it.
Depolarize it?
Depolarization.
Defend your answers, why do you
So
think?
hyperpolarization is when it becomes more negative and depolarization is.
So
when
why
it
would
becomes
it hyperpolarize?
Because there's no way
closing
to escape.
the
More.
voltage
Okay.
gates, and so less sodium can come in, which sodium
Which stops it
So
from
less-
depolarizing.
So less positive on the inside of the cell,
So it becomes more negative.
Yeah.
so it would become more negative, so it hyperpolarizes. So, do you want me to say it one more time, or?
Yeah, because I thought that, I mean, are you talking about hyper, right?
Hyper is.
Hypercalcemia.
Yeah.
So-
hyper.
Talked about.
So there's more calcium outside the cell.
Okay, yeah, right.
Okay, yeah, because we're inputting a lot of neutral charge, so the calcium itself isn't affecting it. And the neutral charge is closing any of the sodium gates that are open. So less positive can flow inside the cell. Thus, it becomes more negative.